Good morning, everyone. Thank you for joining the session today. Today's topic is three ways artificial intelligence enhances your CCTV system. Most of us are quite aware of artificial intelligence. Some of you may not be aware of it. We will cover today um, the basics of artificial intelligence and the analytics, and also how it improves other aspects of CCTV, image quality and image settings, um, bandwidth, and overall how it improves the CCTV system. All right. So my name is Samuel Kumar, training manager for Hanwha TechWin, Middle East and Africa. I'm based in Dubai, and today I will be conducting the class. So this session is recognized for two credits, CEC credits. Let's see, let me show you the certificate. So after the training is attended successfully, within 30 days a certificate will be issued. Three ways AI enhances your CCTV system. This is the training ID issued from Bixi, and two credits. If you have Bixi certificates or certification like RCDD, you can use this course to gain two credits for your renewal. All right. So let's go ahead. So I am working with Hanwha TechWin. It's a conglomerate. It's a group of companies under the brand name Hanwha. It's a South Korean company. The company that I'm working for is a subsidiary of Hanwha Group called Hanwha TechWin, which is manufacturing CCTV, access control, intercom, other ELB security products. In globally, we are in the top five, and as a company, as a group, we are one of the um, biggest 500 companies in the world. We are ranked 260 to 270 range, and within Korea, Hanwha is the eighth largest company. Okay. The product name that we make is called Wisenet. All right, so let's go ahead. How did CCTV all began? It began as an analog system. Analog system is where cameras connected directly to the DVR recorder. Even before DVRs, they used VCR in the old magnetic cassettes they used to have for cameras. But today, we still use DVRs, digital video recorder. What's the difference between VCR and DVR? VCR is video cassette recorder. It's analog recording unit. DVR is digital video recorder, which means it takes the analog video, converts it into digital signals, and records on the DVR. It can record on the DVR using a method, compression or codecs, H.264, H.265. That is digital encoding of the analog video from the camera and recording on the DVR. Excuse me. Okay, I will increase my volume. Let me move the mic closer. All right. Cameras recording on the DVR, right? So far everything is fine. You had your keyboard controlling the DVR. Everything was fine. But back then, the number of CCTV cameras were few. The CCTV system is called closed circuit television, which means point to point communication from the camera to the DVR and to the monitor. There is a cable running, right? There's no break in between. So that's why it was called closed circuit CCTV. And the objective or in those time, the camera video, the camera was installed on very few locations, usually entrances, or let's say if it's in the bank, they would monitor on the very specific safe area, or precious metals, or it could be very specific areas. Okay, and that's it. So if ever there was an incident, they would go and play back that particular video. All right. As we move forward, analog cameras and moving to digital IP cameras, using encoders, we were able to give IP address to cameras, right? In the last 10 to 15 years, IP cameras are dominating the CCTV market because of flexibility, ease of use, higher resolution availability, multi-directional multiple technologies are introduced. So that's where all the R&D R&D funding is being diverted to. All right. So, having said that, the recorder is now called NVR, Network Video Recorder. So, the camera is somewhere on the network. It can be on the same place, it can even be on a different location. But if they are networked, if there is a connection, just like you are networked to me over the internet, you're not sitting in my training room, you're sitting somewhere else. Same way, as long as the camera is connected to the network, somehow connected to the NVR, you can record it, right? And intermediate between analog and IP, um, there was a period where customers had existing analog installations. So there was a converter used called encoder, which would convert analog cameras to IP. What does it do? Basically, it gives IP addresses to each cameras, and it probably also uh, encodes the video. It encodes to digital signal and then sends it to NVR. So NVR is not doing any encoding. If H.264, H.265, NVR is not doing anything. In DVR, it was doing the encoding, right? That's why you had a very, let's say, 4 channel, 8 channel DVR, 16 channel DVR. That's it. Maximum you would have seen is 32 channel DVR. That means all the 32 cameras are being encoded there, right? So the load or the processing happens in the DVR. Whereas in IP camera, the camera itself does the encoding, camera itself is doing the image processing and just sends the video to be dumped on the NVR on a specific IP address location or a folder. All right. The encoder is converting analog to digital. Okay, so again, analog camera, IP camera, and in between there was a period where customers still had analog and they wanted to convert it into IP, so they would use encoders. Encoders would convert the analog cameras to IP by giving IP address and then converting the analog signal to digital signal using codecs such as MPEG-4, H.264, and so on, and then it will dump the video on NVR. That's why in NVR you would see cameras with 64 channel, 200 channel, 300 channel, because all it's doing is just dumping the video and keeping it in the correct address and location and events. Okay. Now, with IP system, things changed. The size of the project expanded greatly. Now, even because of a lot of demand, a lot of manufacturers are in the market, so it's become more affordable today. Having said that, it is the CCTV of choice for large projects. Okay, because if you want another camera in your office, all you need is a switch, connect to the existing switch to expand it, and then connect a camera. You can have another 20 cameras, but you cannot do the same when you have analog, because you need to pull the cable through the ceiling all the way to the floor, and 20 cables, 20 power cables to power the camera you need 20 power cables, and to send the data you need 20 analog coax cables. So it was not feasible. So the design had to be very, very good from the start. But today, if you see, the customer wants to have another room, or he wants to change the facility to another office, and probably is building another you can say a hotel. He has extra land, he's building another property or another area. So uh, or a person is building having multiple shops across the I mean, let's say in Dubai he has multiple shops, he wants to see them all together. So these kind of requirements was literally very difficult in the analog days. Okay, but today it is possible with internet, because we are all connected. You can have the CCTV systems easily connected over the internet and see them and expand them as you like. Okay, now, CCTV system, so far, uh, it's good, and there is one more trend. Number of cameras per project are also increasing compared to 10 years back. In before 10 years, 50 camera, 200 camera was considered a very big project, and today 50, 200 cameras are quite common. Okay, and the the need for security cameras is driven, or it's fueled by the mindset of security, in the sense after the September 11 attack, the amount of investment that went into security increased exponentially, and uh, the you would see CCTV cameras in every corner, every nook and corner of your property. You will see a camera located, and all because they want to provide good security for the users. Okay, now which is good, but the challenge is with too many cameras. With too many cameras, the difficulty is how do you manage them, right? Imagine you have one laptop, it's okay. If you have 10 laptops, you cannot manage what's happening, and I mean, whether the third laptop is updated, whether the third laptop certain settings are done, or if you have 10 phones, how you can manage. So it becomes difficult, right? Let's say in CCTV, if there are one camera in every staircase, and the building has 10 floors, and there are two staircases, that's like 20 cameras. Now that itself becomes difficult to manage. And if there are five entrances, okay, the which entrance, things get more and more complex. So the challenge here is the operators. In every property, having a manpower is one of the biggest cost. All right, hiring a security guard is a cost, and security person is not a robot. He's not going to sit there for 24 hours. So you need to have three people, three shift. And if he's monitoring the CCTV, then if some incident happens, then he has to focus on that particular incident. He has to call the supervisor, he has to call the police, he has to make notes. So during that time, who's monitoring the CCTV? So there is a gap. So during lunchtime, who's going to monitor? So all these challenges are there in CCTV when the number of cameras are increasing, day by day in every project. Project sizes are bigger now, towers are being built, so it becomes difficult. So in order to enhance or improve the efficiency of CCTV system, analytics came into picture. Okay. All right. What is the objective of analytics? Analytics is just trying to make the CCTV system more intelligent. All right. You would have heard of this word called eyes on the area. Let's say I have eyes on the entrance, I have eyes on this person. That means you're monitoring someone. Same way, CCTV camera is actually monitoring different areas. Okay, done. Now, you have invested and the CCTV camera is just recording. That's fine. So, if an incident happens, unless you witnessed it, you will not know. Or unless someone informed you, you will not know that some incident occurred, right? So, if the cameras are more and more intelligent, if the cameras can become the security guard, if the cameras itself can think like a person, and alert the operator, can take even decision, maybe can activate or lock the door, or can start the sounder, or can send a alarm out signal to the operator. So if the camera itself can do the job, or if you connect a speaker, it will send a voice signal saying do not enter. So in that case, it helps, right? It just helps to automate things more and improves the efficiency of CCTV system. Okay. Having said that, analytics is not new in CCTV. It's been there for a very, very long time. Many companies came and went, and providing intelligence on the cameras. Then the manufacturer, the CCTV manufacturers itself, they themselves started injecting intelligence into the camera or analytics into the camera. Okay. Now now let before we jump to artificial intelligence, there are four levels of analytics. Believe yes, four levels of analytics. First is pixel based analytics. Let me just bring out something, explain. So pixel based analytics, what is pixel based is the camera image is just made up of pixels. If it is a 2 megapixel camera, 2 million pixels. How many pixels on the horizontal side? 1920, vertical 1080 pixels. Okay. If there is any change in the pixel, so here there is a green color box, it detected some change in the pixels. So if there is any change in the pixel, the camera or the CCTV camera detects, okay, some activity happened. Okay, some change in the scene happened. Then the camera will say, okay, I detected someone, it will alert. All right, so far it's fine. And by the way, there is a word called computer vision. Camera does not look at the scene like a human being, right? We we are very intelligent. There's no doubt. So the way we look at the scene is not the same way camera looks at the scene. When camera is looking at the scene, it is looking at it as if it's a bunch of numbers. Every pixel is a number. So if a black color, probably number 200 something. White color maybe sorry, black is usually 0. White maybe 250 number. So it knows, okay, this particular number on that pixel size refers to a certain color. That's how it looks, right? So it's called computer vision. So in CCTV, using that numbers, it detects the change in the number from, let's say there is a light switched on, so 0 to 200. So there is a change in the pixel value. So the camera thinks, okay, there is some activity, and it will trigger an alarm. All right. So let's say, okay, so played around with this camera quite a bit. Let's start. Okay. Sensitivity. Okay, done. So there were some previous settings. So I had to just remove that. Okay, so whenever that right now in this particular scene, if the screen something changed, so it detected a movement, right? Some pixel value changed. So this is the basic first level of motion detection. Now, if you had some experience with the DVR, or if you had some experience with old analog system, you would see something known as pixel-based motion detection, or you would see you would see an option where you can select in the screen which area or which pixel area you want motion to be detected. Or when you activate motion detection, you will see 100 blocks showing in the camera. So these are all pixel based motion detection. Okay, just because the camera is 100 pixels, sorry, 2 million pixels, some cameras, they will not check each and every pixel. They will make it as maybe they will cut the camera into like 200 blocks, and they will check in that, let's say here 200. They will split the camera into 200 sections, and then they will check in that section whether there is any movement, because checking each and every pixel can be more processor consuming. So this particular level is just a basic level of motion detection. Then came um, what is that, heuristics, or basically some level of rules that were set on the camera. Okay, that was uh, common. Common is basically I set the rule in the camera saying if any pixel, if any movement in the pixel is bigger than a specific size. So here I'm saying if anyone walking through the entrance should be as tall as the blue color box and should be as wide as the blue color box. Only then the camera should consider it as a pixel change or consider it as a motion. Okay. Otherwise, ignore. So if my blue color box is very small, it will even trigger an alarm if there is a bird flying, if there is a leaf flying, or if there is even there's a cat moving or any animals moving, it will detect the alarm. But if it is too big, it can even miss a person. If a person is walking through and he's not meeting the width criteria, he's too small, it will miss. So this is called basic rules which you can set in the camera, make it a bit more intelligent. All right. So this also has challenge because what if the person is crawling, right? He's not walking through, he's just crawling. Uh, if you crawling, oops, this is song. So crawling. So if he's doing that, it can miss, right? Okay, done. So let's say you want to identify if any, let's say this is a highway and streets, and you want to see if there's someone is crossing the street. You cannot do it because there is car going in the same scene, right? There is a, let's say, just a second. So let's say this camera is looking through the highway and I want to trigger if there is someone crossing the street. So I set up a box. Let's say I'm saying detect analytics, motion detection, enable, and I'm setting a box as big as this much. Sensitivity. So in this case, the car and the human being are almost the same size, right? So the camera will think, okay, every time there is a car crossing, it will think, okay, there is a person also, and then it will trigger an alarm. All right, so there is a challenge when you put object size. Person also will meet the criteria. Sometimes a bigger animal also will meet the criteria, or if the person is coming very close in front of the camera, or if some other object is standing very close, let's say if there is a bird right sitting in front of the camera, also it will trigger an alarm because it's very big and it will cover the entire lens, then it can trigger an alarm. So this basic rules also is not efficient. Another reason, if there is a cloud, the clouds, for example, you would have probably seen this slide. We'll come to all this. So you would have seen this slide of mine. Let's say here, if there is a cloud moving, it will also trigger as an alarm. Okay, because it's big. If the trees are moving, it will trigger as an alarm. So what happened was people were not happy with this and they would disable the analytics because they were getting a lot of nuisance alarm. What is the meaning of nuisance alarm? Alarm is correct, conditions are met, but it is not of any value. Okay, false alarm. What is the meaning of false alarm? There was no alarm, but still the camera detected due to an electronic issue. So that is false alarm. But here I'm not talking about false alarm. The camera detected correctly. But it's not of any value because it's a tree moving or it's a shadow moving or if there is a car headlight in night, a lot of shadows all across wherever the car goes there is a alarm, right? Because of the light and shadows. So a lot of nuisance alarms. So this is also a headache. That's why people were not very convinced with the older method of analytics. Okay. Then came machine learning or artificial intelligence. It's still okay. Artificial intelligence. Basically, trying to improve the camera's intelligence to as much as a human being, okay, and to think like a human being, to detect an object like a human being, right? Just because the person or there is a bird in front of the camera or just because the tree is moving, the camera should not think, okay, it's as big as a human, so it's a human. It should not think like that. That's why artificial intelligence, it will not create nuisance alarm, right? It will check and accurately understand, okay, this is a person. You cannot trick the camera and say, no, it's not a person. So, and then the camera will decide, okay, there is a person moving in the scene and trigger the alarm. Okay. Now, under artificial intelligence, can the camera think like a human being completely? Not really. A camera is not entirely a device which can behave like a human being. It is partly human. It is partly AI, right? Okay. And okay, under AI, there are different ways to train the camera. Let's say if I tell my camera is artificially intelligent, that means it is having some level of higher intelligence compared to the traditional, pixel based detection. Okay, it is having some additional level of intelligence. So under that artificial intelligence, the the way to train the camera, let's say the way to train the camera, you can use machine learning method. Machine learning method is uh, is a programmer trying to train the camera, teach the camera, and say this is a person. And then he will show another. Okay, let's take for example, he will show in front of the camera. He's going to train the camera to differentiate between a cat and dog. So he will tell the camera and say, look for ears, pointed ears, and if you find it, it's a cat. If you don't find pointed ear, it is a dog. So he's going to teach the camera, right? Machine learning means I teach the camera. The programmer teaches the camera and saying, um, on entering filters. He's going to enter filter. Just like you shop in Amazon, you want to buy a laptop, you start with filters like Apple. You start with filters like you do some filter selection, right? RAM size, screen size, and so on. Same way, the operator has to enter all the filters manually. He has to enter every condition. Okay. Now, after entering all the conditions, now the camera is ready. Camera has been trained, and that training method is called machine learning, manual training by the operator. Okay, now based on this training, the camera will take a decision whenever you put, let's say now I show another photo of a cat in front of the camera. Now the camera, based on what I trained, based on what I informed, it has to take the decision. Okay, that this is a cat. But sadly, I trained the camera saying only if there is pointed ear, it is a cat. Otherwise, it's a dog. So according to my training, according to my information provided to the system, so based on that, the camera decides this is not a cat. According to the camera, it is a dog. Okay. So it is informed decision. So based on the information I gave, the camera decided that it is a dog. So this is the issue of machine learning method. Uh, then came another method called deep learning. Now you might think, okay, I can put more conditions. Actually, it is literally impossible for us to enter all the conditions, right? Because we are working with a scene which is complex. We are not working in a small office environment where all every scene in the world looks like an office. No, in CCTV, the scenes are extremely complex and varied. Today, the camera is looking at the street. Tomorrow, the climate changes. Tomorrow, it is raining. Day after tomorrow, it is very hot. In the daytime, it is different. Climate keeps changing. There is sudden crowd. Suddenly, there's no one in the street. In the nighttime, it is different. Light is changing. The camera is looking at the street now, and there's another camera is looking at a railway station, another camera looking at the airport, another office. So it's a complex environment, different angles. So you cannot control this. So if you can control, then it's okay. You can go with machine learning method where you put all the conditions, everything is perfect, and it will work as per your rules. But that cannot work in the CCTV environment. That's why the fourth method is a deep learning method. Deep learning method is I cannot train, let the camera train itself. Okay, I cannot go and put all the conditions how the cat looks like. There's no way. I have to search in Google and find a book, anatomy of cats, and then enter all the conditions. So for that, studying the book itself, I need another 6 months, and then to program the camera, I need another 2 3 months. By the time I finish, it can take a year and two testing, and so it is impossible. And imagine that is just for one animal, and you have to detect more animals. Then it is literally impossible. That's why machine learning came in an environment which is complex. You don't train, uh, you just show in front of the camera pictures of cats, thousands of pictures of cats, thousands and 10,000 pictures of cats, of different variety of cats. That's it. The camera will learn by itself because of a different algorithm called deep learning algorithm. Okay, it will create its own filter. It will create its own conditions. It will understand where how the cat moves, how the cat walks, how it looks, how the ears, how what are the different patterns, body color, body shape, body sizes, body markings. It will understand by itself, and it will decide, okay, I have seen enough of hundred thousands of cats I have seen. Now, based on what I learned, now I can decide it's a cat. Okay, who does this? We do this. We also learn like this, right? Did someone program our brains? Not really. Someone just told us, this is your uncle, this is your dad, this is your mom, this is a ball, this is a car. Your brain automatically programmed itself and understood. Every time you see a car, automatically your brain is programming itself, creating conditions. Okay, this can also be a car, this can also be a car. When you saw an e-bike for the first time, you're excited. But later on, when you see, you already know, your brain is already programmed. It knows it looks like a e-bike. Just because the e-bike is small doesn't mean it's not a e-bike, right? Just because it's a, let's say a cat has a baby kitten, just because it's a small cat does not mean it's not a cat, right? So you, based on what you learned, you probably think, ah, this could be a cat, a small cat, right? Based on whatever you've seen since childhood, right? So this is what deep learning it is actually so complex that we cannot really know how the camera learns. We can only we can only see from the outside the result. Okay, so just like how we learn, A lot of neurons are being generated. That's why they say a person who reads a lot of books, the person who travels, is more having a lot of information, right? Because they develop a lot of neurons. So same way, that's why deep learning, whenever you see symbols like this, right? It tries to think as good as a human being. Now, because of this, the accuracy of the camera is now greatly improved. In machine learning, if a person is hiding behind the tree, it will think it was not a person. If the person is crawling, it will still think it's not a person, right? So this is machine learning because you have to enter the condition. You did not enter the condition. Okay, if it's crawling, he will not have the same height. You didn't enter the condition. So because machine learning, you inform the camera, and based on that, it camera decides. So there is a lot of challenges in machine learning. So today, deep learning is accurate because the camera itself learns. You just show pictures of pictures of people running, walking, crawling. Automatically, the camera learns. Okay, this is a person. Okay, so even if you show half the hand, it will, for example, here. So even behind the tree, you will see the camera is able to detect it's a car. That color box, blue color box means it's a car. Yellow means it's for a person. So with even half the characteristics, it can identify, okay, it is a person. So here it detected there is a person behind here, there's a child. It is able to detect each separately and think it's a person, right? And most of them are not even looking at the camera. So you're not even seeing the eyes, you don't see the face, nose, nothing. It's fine. But camera knows, okay, these two legs, hands are there, head is there, this is a pattern, this is a ratio, and it figures out that's a person. Okay, so now this is better. This is a way to go. This is how most likely almost all cameras eventually will have this level of analytics. Now, why is this popular today? Because to do this kind of algorithm, artificial intelligence, you need a lot of CPU, you need a lot of processing power. Back then, it was not possible. That's why it was not very common. And if you have less processing power, the accuracy also is very bad. But today, with high-end CPUs in the camera, your iPhone is powerful enough, right? It can do face detection, uh, may not, whatever, but it can do a lot of things, right? So because the same processor, or sorry, the for the same size, you have a better processor, right? Okay, imagine your first PC computer, right? It had Intel, probably I forgot the name. So it's older than your first Intel Pentium, maybe, right? So those processor sizes and today are same, but today you have a higher number of cores, higher number of calculations that can be done. So the same size, but the processor is different. Same way in the camera, now it can handle much more. The processor is powerful for the same small size. Because of that, now you're able to achieve a higher level of intelligence even in the camera side. Okay, previously previously analytics was done by buying separate servers. They would buy analytic license, they will buy another analytic software, and that will do the processor of analytics. But today, that's not the case. The camera vendor itself is injecting the analytics. First, he injected the traditional analytics. Now he's even the camera vendor is now, they themselves are providing deep learning analytics, which actually requires a lot of processing power. Okay, and because the processing power is not a problem today, you are able to get higher accuracy, 90% accuracy, 95%, 99% accuracy is all possible because of good processing in the cameras. Okay, now having said that, there is a caution. Artificial intelligence means any camera which uses machine learning or deep learning can be called artificial intelligence. Today in the market, there are multiple brands. They call themselves artificially intelligent, which is correct. Legally, technically, it is correct. But the method of learning, what they use, is different. They can use machine learning. In that case, you cannot expect the accuracy of a deep learning. If a person is crawling, you will miss. If a person is behind the tree, you will miss. It will not detect. If the person is too small, maybe it will miss. So machine learning method can also be called AI. Deep learning method can also be called AI. So you have to take the caution and figure out what analytics algorithm you are being supplied. Okay, this is a word that they will use in the data sheet. So, MPLU means machine MLPU, sorry, MLPU, machine learning processing unit, machine processing unit, or DLPU, deep learning processing unit. Okay, so you have to check what chip is inside. Is it a deep learning processor or a machine learning processor? For sure, deep learning is the way to go for CCTV because it's a complex environment. You cannot dictate the scene. If it is a factory, you can use machine learning. You're looking for a broken item, okay. There's only a few variables. It will be a very simple background. It will just show, maybe you're looking to check if there is a manufacturing process, something is broken. So it is only looking at the same item every time and looking for cracks or if it is broken. Right? It's not complex. It's not raining in the factory. It's not rain. There's no condition, no distractions or changes in the scene. So it's okay. Machine learning is fine. Okay. Even factories they use machine learning. They don't have to spend on deep learning. They don't have to spend more money on that. Right. But in CCTV that's not really favorable. Okay. And today you don't have to, I mean, there are two options. You can have the deep learning algorithm running inside the camera, so it will be free of cost, but you can also buy separately. You can buy your own server and buy deep learning from vendor. You can put their analytics and you can pay per camera license. Now, which one is the way to go? It depends. So if your camera is already purchased, you don't have a deep learning chip inside, then you have to go with server based deep learning method. If you're a new project, you can go with cameras with built-in deep learning. Sometimes even built-in deep learning, actually speaking, almost every type of analytics is now available from the camera side. Even face recognition is now available with the deep learning concept. All right. So let's okay. So now what AI does, artificial intelligence, basically it looks at the scene and detects the object. First of all, in order to understand the scene, you have to detect what's in the scene. It's called object detection. What is being detected here? Person. What is being detected here? Car. If there's a car, okay, it will detect there is a car. Let's say here there is a person, there is a car. So this is called object detection. And then there is a word called object classification. That means it detected an object and then it classifies it as a person, as a car. Okay, that is object classification. And attributes, there's another word called attribute of the object. He's a male, or the person is a male, person is a female. That's an attribute. The car, it's a truck or it's a bike. So car color, it's an attribute. Okay, person gender, whether what is the shirt color, pant color, it's an attribute. Okay, it's not, we are not detecting whether he's wearing a shirt. We know it's a person and he's wearing something, and what he's wearing, what color shirt he's wearing, that's what we are trying to find out. Okay, so this is called attributes of the object. So please remember these three words. Object detection, first of all, detect the object, whether it's a person or a car, and then you classify it. Okay, it's a person, and then you add attributes to it. Is a male and is wearing a glass, he's carrying a bag, there's a specific color, and so on. Okay, these are attributes. Now, okay, there's a question on in the chat window. What is the difference between X series and P series? Okay, we're just jumping to the point, but to answer your question, X series artificial intelligence uses deep learning. P series also uses deep learning. Both of them, in terms of intelligence, is same, but the level of details. For example, P series will give you attributes, color of the shirt, color of the car, but X series will not give that. It will only say it's a car. It will not give color of the car. So that is the difference between X series and P series. Okay, so this is why we have to understand these words. Some vendors, they will give you different category. For us, we have different categories. We have two levels of artificial intelligence. All of them use deep learning. And if you want to find the color of the car, the color of the shirt and pant, so that is attribute support. So we have models which support attributes. We have models which will stop and say, okay, I detected a car, I detected a person, I also detected it's a truck or a bike. That much it will give you, and that's it. But it will not tell you what color of the bike is. So that is called extra attributes. So you have to be very careful. You cannot take it in face value and say, okay, I have an AI camera, it will do everything that I want. No, you need to check the datasheet and figure out what it is doing, what kind of objects it can classify. It can classify object as a person or a car. Okay, what level of attributes it can provide. Okay, it can detect the car and it can tell me it's a car, it's a bike, it's a. Okay, let me show you a video to explain this. So here. This is a P series camera. It is looking at the scene. It is counting cars. It is counting if there is a bike and so on. So it is classifying and giving additional attributes. What is this? Bike, okay, car, bus, truck, motorcycle, and so on. So if you want this level of detail and you want to know the color of the car, then you have to check in the datasheet whether that particular camera supports. So that's called attributes. Okay. All right. All right. So now with artificial intelligence, what is the benefit for the customer? The benefit is almost, you can say there's no boundary. It's about what the customer wants. If the customer is interested in just investigating for a specific person, if he's interested in figuring out, I'm looking for a guy wearing a red color shirt. It's fine. He can, okay, let's wait for this video to complete. So, so all the red color shirt is there. So it is improving the efficiency of his investigation process. If his job is only to check um, person investigation, who stole or who lifted this particular, stole this from the storeroom, if he's just looking for this, it's okay. That is one level. Or it can be that, okay, I'm let's say a school property and they are only allowing buses in this school area. There should not be any other type of vehicles. So he can look for the search engine and he can say, show me all the vehicles other than the bus. So for example, let me see if I can. So here you can look for a truck and you can search by that, just based on trucks. So you can, it depends how you want, right? Or let's say one of the customers said, I'm usually missing child. So you can go to the search engine and you can say, I'm looking for a child, specific age group. age group. So you can do that, or l- or it could be one of the customer required that he wants to figure out if there are any accidents in the scene. So if there is a car accident or if there is a motorbike accident, so this is completely customizable. How the customer wants the camera can be trained, but the training has to happen in the factory side. It cannot happen on the your field. So we do the training and we supply the cameras or we ship the cameras. So this is how it works. Okay, so let me just open the. Okay, let's take a short break and then we'll come back and see the benefits of using AI. I will show you the different videos of different levels of implementations of artificial intelligence on the analytics side. After that, we will see how it improves the image quality as well. So let's catch up in 10 minutes. All right, let's continue. Next, with artificial intelligence, what can you achieve more? What can you achieve further? Let's say in your CCTV project, you're requiring or you're required to provide an analytics if someone is crossing a specific line or someone is entering or a car is parking in a specific area and you want to trigger an alarm. Okay, in the traditional method, you cannot really put a condition. You cannot put a condition saying if it is a person, then trigger. If it is a vehicle, then trigger. But today you can do, for example, here, let's say vehicle and crossing. So any vehicle that's crossing, it should generate an alarm. But if there is a person walking through it, it is fine. Now, this is all real world application, right? So you are the law enforcement and you have this is a pedestrian area and bikes are not allowed, motorbikes are not allowed. You can trigger an alarm. So this will help you, your project, to have accurate detection. So here, let's say you want to detect if here if a car is going, it's fine, but if there is a person, so it can be a highway also. If there is a person going through, you don't need an, I mean, you need an alarm. But if there is a car, it's okay. So car, no issue. Now let's say these two people are walking in, so it will generate an alarm. So you got the idea, right? So this kind of analytics are quite useful for real world applications. Another one is the car parked in the bus stop. So if you had a traditional analytics, and if there are five people standing, the old analytics will think it's a car because it's a big object, right? Same thing happened here. Here, if you notice, it considered both of them as one single person, right? So this is the thing with the traditional analytics. Another video to explain that would be, let's say, okay. On the left side and on the right side. Right side is the old method. Even if there is something moving, it's not a person, but it will show it's an alarm. You see, so sometimes the persons are triggered as two as one person. Here, both as individual persons, right? So here there is a chance it will detect both as one. So these kind of things can be overcome with the artificial intelligence. Okay, so you get more accurate analytics. If you are doing counting, you get more accurate counting results, and uh, and also you can do these kind of analytics more wisely and better. So if there is a car parked after 50 seconds, after 1 minute, it will trigger an alarm. So same way, there are requests for from customers asking for, let's say, let me show you vehicle counting. We saw that stopped vehicle. So there is a area. If someone is just, it's a driveway. Now people are supposed to park. Okay, there is a parking here. So let's see if the car has stopped in the driveway after some duration, then it will trigger an alarm. So I'm going to forward the duration. So you see the red color box, that means the alarm has been triggered. So let's say, so after a few seconds, it detected and said, okay, there is an alarm. So you got the idea. Next is traffic jam detection. Basically, if there is too many cars piled up, then it can give you the alarm. The next is accident detection. If the camera detected there is a traffic flow issue, and some vehicles are blocking the street, then it will trigger it as an alarm also. Okay, then one of the customer also requested if the cameras will be mounted, and if someone threw a large garbage on the streets, it will trigger as an alarm and it will pick it up. So you got the idea. So the idea is completely up to the customer. So one of them also requested slip and fall. So if someone fell and nobody knew about it, right? So someone had a fight and someone fell on the street or something happened and he fell, so the camera will pick it up as an alarm. Although other guys are moving, that's okay. But if someone falls, that will be triggered as an alarm. Okay. So if you're using for retail applications, you can also use for the same camera can do counting, and the same camera can also monitor. So it can also monitor the entrance as well as do counting. You know, the older method of counting is the camera has to be exactly on the top. It has to look at the head and the shoulder to count as a person. That's why counting cameras were, perpendicularly mounted on the entrances. But today with AI camera, you don't have to do it. So just like the same camera monitoring the highway can do car counting, you can do people counting. Okay, and next is on the image side, image. How does it help? Not only analytics, camera AI can also help in improving the image quality. What are the three things that affect image quality? Shutter speed, exposure settings, gain, noise control, and bandwidth. So all of them can be automatically adjusted if the camera detects a valuable object, person or car in the scene. All right. So this is something that it is very painful step for most of us because let's say where is the okay, yeah, okay. So for example, let's say shutter speed. If you increase the shutter speed, if you make it fast, your image will become dark and your motion blur will reduce, which is good. So this is blurring of the image that will be reduced. But if you make the shutter speed slower, the image becomes very blurry, but the scene is very bright. So the challenge is you have to find the correct spot. The light depends on the scene, the movement of the people depends on that scene. If it is ideal scene, not much movement is okay. Entrances, people are just quickly coming in. Driveways, people are moving fast. So this setting, you would do it. That's why most of the ID cameras, at the entrance cameras, you are spending some extra time to adjust the settings, right? Because you want to see the face clearly. So this is what you're doing. Next is gain. If the image light is too less, automatically the camera will increase the gain, right? For example, your volume in the computer, this is not it. It is having gain, but you have to do it manually. When you cannot hear me properly, clearly, you would increase the volume, right? Manually increase. Same way, if the camera cannot get enough image from the scene, it will increase the gain automatically. It will increase the sense. I mean, whatever signals it gets, it will amplify the signal, right? So when you increase gain, image will become super bright, but image noise also will increase. Too much noise in the image, graining. So when you have image noise, you have to put one more technology called noise reduction. So noise reduction technology will compensate that image noise. So there are many things. It's like a fine balance. You increase one, other will get affected. You increase the other one, the next one gets affected. So it's like a triangle. Okay. So it's like a triangle. If one side is too much, the other sides will become less. So if one side is smaller, everything else gets affected. So this is how the image settings work. So artificial intelligence can actually solve this issue. Um, let's say, for example, here I'm trying to look at the number plate. But at first instance, everything looks fine. You're happy with the scene. But when you do pause and you play and you try to check the number plate, this is how it looks. Why is this? Because the light is actually 5 lux. If you're not sure what is 5 lux, let's say this is 300 lux. 300 lux is your current in your office, in your house, you will have roughly 200, 300 lux. Okay. I just want to give you something. Okay. You see here, right now, 300 lux is it's a bright scene. 10 lux, 10 to 5, it's okay, not big difference, right? So this is actual light. It's very dark, okay? But this particular camera, it's changed its setting as if it's day. How? Because automatic gain control, it fixed itself. It said, okay, I'm going to increase my gain. I'm going to make it high, and now it looks like as if it's day. Okay, so again, all this is okay. Let's say I think I have covered this in other trainings, so I can just show you about gain control, shutter speed quickly and move forward. So exposure, let's say I'm going to switch off the gain control, and let's say this is my iris setting. Let's say shutter speed manual. So if you see, it is dark, right? Shutter speed. If my iris is opening of the eyes of the camera to allow light. Bigger the number, smaller the opening. Smaller the number, bigger the opening. Now this is usually set as auto iris adjustment. We don't set. We let the camera decide. Now if the scene is dark, the camera will open its eyes as much as possible. Okay, so it will become very white, and then it will adjust automatically. Okay, let's say okay done. So you see it's now become white, and now everything looks good. So if the camera opens its eyes clearly, everything will be very clear. Okay, now let's go back to dark. Now the scene is not very bright. If I change, okay, to high gain, I think there is some lag over the Wi-Fi. Just controlling the camera with the Wi-Fi. Okay, so you see the dark scene is now become bright. So this is the power of gain control. Okay, night can become like day. Now then noise reduction is also very high. Shutter speed, how fast the camera, I mean the shutter moves, 1/5, I mean 1 second divided by 5, or 1/12,000 times per second. Okay, so higher the shutter speed means you can capture fast moving object. Lower the shutter speed means your fast moving object will be blurred out like this. Okay, when you look for fine details. So you would probably change the shutter speed, increase it. Then the number plate is somewhat visible. You are switching off the noise reduction. If you switch off the noise reduction, everything looks good. But the challenge is the image is very grainy. You need noise reduction. It's too grainy. So for this, you need to adjust the gain control. Who's causing the noise? Gain control. So if you reduce the noise, if you make it low, to make low noise. Okay, the image is perfectly clear for the number plate and noise reduction is off, shutter speed is higher, but the challenge is the entire image looks as if it's night and you cannot really see anything except the number plate. So you got the idea. So you need everything at the right balance. So that's why you have a different shutter speed now, 1 by 20, noise reduction somewhere in the middle, somewhere in the middle. So now you can get the best of everything. Now, um, what artificial intelligence does is it automatically adjusts the noise reduction to stop the graining, to stop the noise artifacts. So it's called wise noise reduction. Uh, Artificial intelligence looks for the person and makes sure that correct level of noise reduction is applied. Okay, so let's, so yeah, automatically it fixed the shutter speed so that blurring is not there. Okay, so this is the objective of artificial intelligence, even on the image enhancement side. Okay, next is storage. Even in storage, codecs, everything is fine, but how the artificial intelligence works is it will apply the right level of bandwidth control. Let's see. Okay. So wherever the person is moving, it will only apply the noise reduction in that, I mean, bandwidth reduction in that area, I mean, where the person is not moving, and then it will adjust the bandwidth. Let me pull out that information. Wise. Okay, let's go to the video. Stream 3. So what it does is, so if the Y stream is not there, a 4K camera is roughly taking 4000 um, kbps or 4 mbps, and Y stream is enabled. Y stream here is enabled. So currently it is reducing its bandwidth to as much as 600, 1600, 1000, that range. Okay. Now, if there is a person in the scene, okay, Y stream ensures that for that, okay, it detects there is a person and automatically adjusts the bandwidth, right? When humans are detected, minimize to increase image quality. So the compression is automatically reduced, so image quality is not affected. After they go out of the scene, again it goes back to the saving mode. Okay. Now the challenge is if you don't have a Y stream with AI, if there is some movement in the scene, the special techniques, Ystream 1, 2, or the older or any other brand, special image compression techniques, if they cannot figure out it's a person, so whenever there is motion, they will take it as okay, there is a person, and they will increase the bandwidth. But in Ystream 3, even if there is a, if you see this robotic arm moving, okay, it knows it's not a person, so it will keep the compression on the higher side. When there is a person, then it will automatically adjust the compression. Okay, so this also helps in reducing the storage a lot, because as you know, storage is directly proportional to the bandwidth. If your bandwidth is 1 Mbps and your bandwidth is 4 Mbps on the other camera, your storage is 4 times. So it is directly proportional. There is no ups and downs. Whatever is the bandwidth, exactly proportional to the bandwidth. So even if you reduce by 5%, your storage will reduce by 5%. If you reduce the bandwidth by 30%, your so here, for example, 4 to 1.5. So it's how much percentage? Let's see. Uh, so around 63%, it reduces the bandwidth. So that means 63% drop in storage. Okay, so it is quite powerful artificial intelligence. It's not just for analytics, it can also be used for other purposes in image quality enhancement as well as storage reduction enhancement. You don't have to manually set each and every settings. Automatically, the camera will adjust the shutter speed, exposure settings to give you the best image quality. All right. So bandwidth, analytics, as well as image settings, which is the noise reduction, exposure control, shutter speed, all that is automatically adjusted by the camera itself by understanding there is a valuable object in the scene of interest, which is a person or a car, because they are the main cause of threat as of the current risk assessment. Person or a person driving a car is what we are monitoring, right? So that's the objective of AI, to enhance CCTV system. And in Hanwa, there are all the AI cameras are using deep learning algorithm. There are two versions available. In the X series also you will have AI. In P series also you have AI. In X series you have whatever we covered today is available, except color, finding out the color of the shirt. You can find out it's a person, it's a car, it's okay. But if you want to figure out, I'm looking for a red color shirt, I'm looking for a specific age group, or you want to customize your analytics. Okay, you want to customize. You want to say I want to look for garbage detection, or I want to look for e-scooter detection. So if you want your own special customization, then we have the P series AI. P series AI is having a bigger processing engine to customize as per your requirements. So it can also be done. So we have a dedicated AI lab and with AI team, R&D engineers, and all this is developed in-house. We don't depend on anyone else to do any of this. It's cameras, image processing, sensors, algorithms, everything is in-house developed. So we are here to support you on that. All right, so that brings us to the end of today's class. If there are any further questions, you can post it in the chat window and we can answer them live. Thank you for attending, and class is completed. Okay, all the analytics that you saw, it's on the camera side. So there is no special licenses required for any of this. It's all built in, freely included in the camera. If you buy an AI camera, all of this is included. Okay. And yeah, you can check the data sheet, what is included and what is there and all that. Some custom analytics like accident detection, they were developed for some customer, so it was for them. If you want also, we can have it in your camera when you are buying, so it is possible.